That one is the most applicable immediately right now for us. So where these things live is in the PRGM button menu. You have to hit the PRGM button. I think it's right below stat, I'm pretty sure. Yeah. So if you press that, there's all kinds of stuff in here. One of those, the one that's called GOF, you will use in this class later on. It's called Goodness of Fit. It's a nice little calculator. Some of your TIs have it built in already. A lot of the older ones didn't, which is why I wrote the program. It's becoming outdated as the TIs get newer. Sample size calc is one I want to look at. Let's look at that one now. Number 5. It's 5 on mine. I don't know what it is on yours. So 5 sample size calc. Can I pull this towards you just a smidge? I can't focus this anymore. It's a little blurry. I don't know if that drives you guys. Is that okay? Right there? I'll pull it back as soon as we're not using it.
It's all right. Just don't throw it at me.
I won't throw it at you. Never. So go ahead and scroll down or press 5 and press enter and select it. Then you press enter a second time, and that's going to come out and ask you for confidence. How confident do you want to be? Of course you want to be 100% confident, but you can't. And I think if you put 100%, it's going to give you an error, because you mathematically can't do that. Do you know mathematically why you can't be 100% confident? Mathematically why you can't be. We know you can't be because as long as you're sampling, there's always going to be a chance of being off. But do you know what characteristic of the bell curve makes it impossible to be 100% confident? You might remember this. Yes, the curve is asymptotic. Think about the bell curve. We draw the bell, and then we draw the tails. And then, because we're working in a hurry, we draw the tails hitting the axis. Do they? They don't. They go off forever. You can be out an infinite number of standard deviations to either side. And there's still area out there. It's a teeny tiny little bit. You could be 99.99999% confident, but you can never be 100% confident because the tails don't pinch down. But we don't care about that. We don't often want to be. You have to work very, very hard to get out very, very far to increase by like a 0.9. The difference between going 99.9 and 99.99 and 99.999. You 243 students may have done, did you guys do the flight seat problem in my 243 class? So I cycle that problem through as I get new data. Making flight seats wide enough to accommodate a certain percentage of Americans based off of male and female hip widths. So the average male or female hip width is blah with a standard deviation of blah. How wide do you have to make the seats be to be 99% sure that Americans, that 99% of Americans will fit? And then I say, how wide do you have to make the seats be so you're 99.9% sure? How about 99.99? How about 99.999? And what you start realizing is, you make the seat 17 inches for 99. It might be 18 for 99.9. It goes up to like 22 for 99.999, and then it ends up being like 36 or 40 for 99.9999. Because you have to go so far out to pick up more area, because the tails pinch down so tightly. So hopefully you start to realize how the resources run out. The mathematics is like, yeah, put some more 9s on there. And the resources are like, we can't fly 4 people, right? Because if you go out with too many 9s, then you got 1 seat per row, which is freaking awesome, but then the entire plane is like first class, or I guess 0th class. Even first class has 2 seats in a row. So there's a limitation between practicality and mathematics, like the theory and the practice. So that's why we tend to fall. 95 is a nice number, although we will come back to that as we go through and sometimes talk about why 95 isn't the best. So we'll just go with that now. Either 0.95 or 95, it'll accept either one. I coded it like that. The margin of error, you have to put this one in as a decimal. I realized there was a mathematical problem that happened if you didn't. So this one you got to put in as a decimal. So how off you want to be? Maximally, how off would you like to be? 3%. So you put in 3, right? 3. No. 0.03. Yeah, don't forget the O. If you put in 0.3, it's 30% margin of error. And if you do that, that's fine. It'll just tell you go out and get 11 people. That's all you need. Because you're accepting a huge range, right? So what you want to do is 95% at 3% maximal margin of error. Boom. Go get 1,068 items in your survey. You've got that. You might even have less than 3% margin of error. The 3% margin of error would be centered on if your p hat came back at exactly 0.5. That parabola. It's the highest it can be. That'll give you the maximum margin. As p hat goes to one side or the other, it begins to shrink down. That's a function of the mathematics of the margin of error. But that's it. That's it. This does that formula for you. You don't have to worry about running the numbers yourself. Cool. Fair? Somebody sent me a great question via email. How do you know what sample size to know if you haven't run the study yet? It was that whole margin of error calculation versus sample size at the end of the day on Thursday. How do you know? And that's my question is, that's a great question. You don't,
me crazy yesterday.
right, it's a chicken egg, right?
Yeah.
You gotta know a sample size to get a sample, but you have to know p hat to get the sample size. That's when you just say, let's do worst case scenario and put p hat equals 0.5. Now you don't need it. Now all you need is confidence and margin of error. That's where the first part of that video comes from, right? Where that's why the vertex, that's why you pick 0.5.
You set p hat to 0.5.
Equal to 0.5? Yeah, you just assume the worst case scenario. And you sample for the worst case scenario. This will allow, this will assume. See, the function is, this is the mathematics here. Let's just look at the formula real quick formula-wise. This is the formula for margin of error right here, p hat q hat over n. What you watched, the vertex video, focused on this part of the video, this part of the equation. P hat times q hat is equal to a number. It will be largest when they're both equal to 0.5, which means the margin of error will be largest when they're both equal to 0.5. If they start deviating from 0.5, either one, the product goes down. Suppose it was 0.6 and 0.4. That product is 0.24, not 0.25. 0.3, 0.7, now it's 0.21, it went down again. And you're getting into the tails of that parabola now. So all you do is, you go in, now I've seen stat textbooks do it both ways. They say, well, assume p hat is, like, yeah, why would you do that? You're doing a study. Don't assume p hat is anything. Just call it the worst case scenario. They'll say something like, I did a study 3 years ago and p hat was 0.37. I bet you it's exactly the same. Why would you assume that? What if it's changed, right? What if it's changed? So let's put the worst case scenario in, generate the maximum margin of error. And that way, if we actually do get significance, it's the most powerful significance we can have. That's the assumption. Ask me that question. You're not satisfied, that's okay. Or if anybody else isn't happy with that, tell me.
So then is n the only variable, really?
These, you have to
can
supply
set
these
this
two,
before,
right?
And you can set p hat and q hat.
You set this to 0.5, that makes that 0.5. You set that by picking your confidence, right? As soon as you pick your confidence, you know what the z-score is.
So then n is your...
And you've set the margin of error to a number. Which means the only variable left is that guy. That's what we solved for at class on Thursday. Yep. And that's also what this is doing for you right here, just without doing the algebra. Because I've noticed that in the past when I've asked 244 students to do this, it gives them too many fits of like Math 65, like nightmares, and Math 95, like, oh, radical squaring and square this and flip this and proportion this. And there's a lot of algebra in that, just in the solution of that formula, which makes me happy. It kind of gives you guys like hives and makes you break out. So, decent? Getting there, maybe. Maybe getting there. If you're not satisfied, just ask again. Ask it a different way, whatever. But yeah, the reason is there are n is a factor of 4 things. These two are chicken egg. Without knowing this, you can't get that.
Yeah,
So
that's what I'm trying to figure out.
So let me ask you a question. Let me ask you a different question. When in doubt, should you sample more or less? Assuming you can get quality data.
More.
When in doubt, should you sample more or less?
More.
More. Does that make sense? When in doubt, you sample more or less. Because Chris, what would more give us? As you said,
A smaller field.
a smaller margin, right? So when you set these equal to 0.5 and solve for n, it guarantees you the largest sample that'll get these two things done.
Okay.
Does that make sense? You buy that? Good, good. I can tell. Good, good.
I think part of what's the confusion of it, took me a while to get my head around, is that we know from the math universe that n can be potentially any number.
Could be infinite, theoretically.
So we're choosing a really specific number for p and q, but the truth is p and q have to equate to 1, because...
They do.
So our range of numbers that it can be is actually a lot smaller than what it might seem like.
Very good, and this is something that's very tricky for a Math 243 student at the beginning of the course to buy. When I pull out the Gallup poll on like the first or second day of class, and it says we sampled 1,300 people, and I go, oh, that's plenty, and they go, wait a minute, there's 310 million Americans. How can you sit here and tell me there are 1,300 is enough? And then I was like, do you really want to know the answer to that right now? And they go, yeah. And then I start deriving from, like, stop! Stop! I'm like, okay, you asked. I think that's a counter-intuition. But yeah, I think it's exactly right, Ben, because we're tied to that PQ equaling 1. We live on 0 to 1, right? That's where 0 to 1. We live in that range. And I think that limits us in a way that's not super intuitive. I just dealt with, I built a survey for Ben Film. Anybody go to Ben Film last weekend? Ben Film Fest? I didn't either, I didn't get a chance to, but I make them a survey every year. So they can collect demographic data from the people that go and figure out how to market the film better. And this year, they decided to not do my Survey Monkey one, instead do a paper and pencil one. And I said, that's great, I'm not collecting your data though. Like, what do you mean? I'm like, because I'm not gonna sit there with like 8,000 clipboards and write your data into an Excel spreadsheet. The reason I use Survey Monkey is because I can get it right out of Survey Monkey, drop it into Excel, and then start graphing and looking at things. I got 130 responses last year from Ben Film. And the director said, well, that's not a very big sample. I'm like, well, you got 20 the year before. So I got 6.5 times more than you did the year before. And it's not so bad that it's not a lot. It's nowhere near what we're looking at here with 1,068. But that just means I have to accept a larger margin on my results. If you're happy with the demographic data you've got, if you think we've got a good randomized sample, and this was a question I kept asking, do you think SurveyMonkey is the best for your demographic? According to my numbers, we've got a nice even spread of ages. There's just as many 20-somethings as there are 50-somethings. So one of the concerns was older folks won't use SurveyMonkey as much as younger folks will. But that was almost rebutted anecdotally because they saw older folks, I guess me and older, on their cell phones I had it set up so that there was a QR code on the screen at the end of each movie, and they could just install a QR app and just go burp, and it would take them right to the survey. And they saw young people, old people, all those folks using the app. It wasn't much data, 130 is not a lot. But then again, the population of Ben Film isn't even that much. So I couldn't sample 1,068 if I wanted to because there aren't that many. And then you start playing the non-inference game. Okay, then we bow out of 244 and go strictly with 243, which is what I did with them. And they seemed happy with that until this year. So, yeah, it's cool how many questions it raises. I kind of like that about it. Good? No, it's off now, but good, makes sense? Use it in good health. Use it in good health by all means. And we'll get into the other ones as we go through the course together for sure. What questions do you guys have at this moment? Anything else bugging you? 244 tends to bug students at the beginning. That's good. No, I like that. I like that it bugs you because